Everyone to our weather briefing today. My name is Liliane Hofer and this weather briefing will be led by Andreas, Wirth and me. We're both working at the Austrian National Weather Service, so welcome to everyone. If you have any technical problems, please write something in the text chat box, otherwise I hope everything will work. And so let's start with a warm-up question. So you see here this nice water vapor image from today, 6 UTC in the morning, and so don't concentrate too much on the on the satellite image. Just take a star or something and point it to the location where you're sitting at the moment. So just that you know, I'm sitting here in beautiful Salzburg, in the middle of Austria, on the northern side of the Alps. Okay. Okay, most stars are now in Eastern Europe. I see one star in, I think that should be Exeter, Edinburgh, Offenbach, the Baltic countries, Italy. Nice, very nice. Okay, so if there is anyone who is coming from outside of Europe, you can put a star over here so that I know that you're not in this location. Someone from Russia, from Hamburg, so really nice. So people from all over Europe. So let's continue with this special edition of the weather briefing. Some of you know, because some of you take part in the satellite course that is running at the moment, and the block 2 has the topic cloud types and their characteristics. So this weather briefing will have a special topic, and I will concentrate on monitoring cloud types and their characteristics in the course of the day. So you see here this really impressive image of these thunderstorm cloud, this cumulonimbus. You see the anvil section, some cirrus, you see the mammatus clouds over here, and you can see so many nice features if you're in the vicinity of a cloud. And it would be brilliant if we couldn't just see the clouds in the direct surroundings that way, but also from above with the help of a satellite. And so that's what we try to do today. We try to see more cloud features with the help of satellite images than just, distant different shades of gray and white, but we really want to see cloud features, and that is our special topic today. So I started preparing this weather briefing yesterday. So you see I started with the image from 6 UTC, so it's Tuesday, 24th of May, 6 UTC, and I thought a good start is probably the infrared 10.8, because most of you might use this very often because it's convenient. You get information on surface skin temperature and cloud top temperature. It's available night and day, and so it's very convenient. You don't have to change the settings. It's always there 24 hours a day, and you can see some low-level clouds in these more grayish colors. The white clouds are high-level reaching clouds. You can say where you have frontal zones. We have here this occlusion, wave development, cold front, warm front. You can say all this by just looking at this image, but when you want to know something about details, that's probably the wrong image. You can say, okay, it's cloud in that area, and there's fog probably in this area, but if you want to have details, it's probably not your weapon of choice, this infrared 10.8. So what I suggest to use at 6 UTC in the morning is the dust RGB, or at least I'm doing it now. And please don't be misled by the name dust RGB, because I think this RGB is so much more powerful than just for monitoring dust or for seeing dust. So you see the same weather situation, the same weather pattern. We still have our occluded system over here with the warm front. We have some occlusion here. And it's the same weather situation, but you see so much more information on this image due to the different colors. So the colors give you much more information than just a white and gray scales. So let's start with the probably most prominent thing on this image, these black clouds over here. They look really distinct and they're really an eye catcher. And those of you who are not used to the dust RGB might wonder what's this, and the answer is really this is thin cirrus, and it's really interesting that this thin cirrus has such a prominent color in this RGB. So probably a better name than dust RGB should be dust and cirrus RGB, because it's really good for monitoring cirrus clouds. But it don't just see the cirrus clouds in black over here. You see these red clouds, and they are cold, thick, high-level clouds. You have these ochre clouds over here, which represent thick mid-level clouds. What more do we see? These more yellowish clouds are low-level clouds. Then on the edges of our mid-level clouds, you sometimes see these green colors. So the yellow clouds are thick mid-level clouds. The green colors represent a thin mid-level cloud. So you get so much more information. You know in which level the cloud is situated. You know whether it's thick or thin and things like that. And you also get information on the surface if you take a look at the desert over here. And so it's just one image, but you have so much more information than by just using the infrared 10.8. So some of you might not be used to RGBs, and so I will go a little bit into the theory and show you the recipe of the dust RGB. Just as a quick reminder, RGB means that you have different satellite channels on different color beams, and by combining these colors, like you see it here, you can create every color in the world by just combining red, blue, and green. And so the idea is that you put different satellite images and different colors, and by that you can highlight certain features. Like, for example, in dust RGB, you can highlight either dust, but also thin cirrus clouds. I have to say that this is probably not the most easiest RGB, because you have here brightness temperature difference. But as you see, this RGB just uses thermal channels, so just infrared channels, so it's available during night and day. And I've started this weather briefing by using or by showing you the infrared 10.8. And you see that the infrared 10.8 gets more powerful if you combine it with other satellite channels, and it's here used on every color beam. So it's a really powerful satellite image. I've already told you can detect dust, but also thin cirrus clouds with this dust RGB, or even the moisture content of the air mass. So let's take a closer look at this image, and now I want you to actively take part in this weather briefing. So you should have some tools, the tools you've used before to show me where you're from. Please take those tools again, those stars. And I want to talk about two features you see in this satellite image at the moment. So there are two features I haven't talked about, some colors I haven't talked about yet. And I want you to highlight the features you think I will talk about. So I'll give you a minute of time. Take a star and put it on the thing you see on the screen. Okay, obviously. Yes. I haven't talked about pink colors yet, that's true. Okay, some people are highlighting the desert area, these light blue colors. They represent the desert. The desert has another emissivity than the ground over Europe. Okay, interesting, because you've highlighted one feature I will talk about, but not the second one. But the second one is really, yeah, it's really hard one. So, okay, thank you. I will just erase your markups. Okay, the border between the desert and the, let's say, normal ground, normal soil. Okay, no, that's not what I want to talk about. So the first thing, you're completely right, is this over here. And as the name implies, it's dust RGB, and you see the dust in these really pinkish colors. There is this low over this region, and it lifts off all the dust, and then you can see it in the dust RGB. And the second feature I want to talk about is this one, these green colors. I mean, I have told you before that green colors, like over here, they're a sign for thin mid-level clouds, but in this area over the desert, you see they look a little bit like fibers and not like really mid-level clouds, but more like cirrus clouds. And those are cirrus clouds. That's a special case over the desert. The emissivity of the desert soil changes the color of the cirrus clouds sometimes. So these are normal cirrus clouds like those here, which appear in black, but over the desert soil, they change the color and they appear greenish. So just if you were wondering, the desert soil or the desert can change the color of cirrus clouds. Okay, some highlighted the light blue, as I've said before, the desert soil. So still 6 UTC. I said we are monitoring clouds in the course of the day, so let's see what the 12 UTC image shows us. And I will start again with this dust RGB over the Saharan desert, because there you see that during the daytime the dust appears much more brighter, much more pinkish. So it's really nice RGB for monitoring dust. You also see here some dust fields or over there, but that's just off topic because we want to concentrate on cloud monitoring. So 12 UTC, we can now use also some solar channels, and what's better than the high resolution visible channels? So that's it. You have very high resolution, a sampling distance of 1 kilometer. Normal, you have sampling distance of about 3 kilometers, so it's much better. And you see this nice cumuli over here, and you also see these Bernard cells over the ocean, the frontal patterns and all this. But again, you just have this black, white, gray color combination, and sometimes you might be wondering, couldn't there be anything better than that? And yes, there could be. There's another RGB we can use here, and it's called the high resolution visible RGB. It looks like this. And before I continue describing what you see there, I have another question for you. What do you think? Again, RGB, it consists of 3 channels on the 3 different color beams. What do you think? You have the HRV image in there, but do you think, is there a thermal channel in this RGB? You don't have to know the recipe of this RGB, just look at this image, think about it, is there a thermal channel used in this RGB? So please just click the yes or no button, not the hand button, the yes or no button. Okay, so 5 yeses, 6 yeses, 7 yeses. Okay. Either you really know the recipe very well, or you know where to look at. So okay, all of you say yes. So now I ask you, in which area of this image can you clearly see that the thermal channel is used? So take a star and put it to the area. Okay, very well. Okay, it was a very easy question, because yes, the solar image, the reflective image, it ends here because the sun is not high enough, and here you have the information from the infrared channel, and as you can see, it's blue, so the infrared information has to be on the blue beam. Very well, very good. Okay, so what profits do we have from this RGB? So you have the really detailed cloud structure, the really detailed cloud information, but as also the infrared 10.8 is used, you also have some information about the cloud temperature, about the cloud height. So you see these yellowish, whitish clouds are all low-level clouds, and due to the infrared channel, if there are some bluish features, that means that there's some cirrus clouds also over there. So you see here this cumuli over Russia, and you see there are mainly white to yellow, so just cumuli, but there are also some showers, which you see because there are also some bluish dots in it. So I always like this high-resolution visible RGB during summertime because you have a very detailed image. You can see overshooting tops and things like that when you zoom in. And you also get some height information thanks to the infrared 10.8. So 12 UTC, we can use the visible channels. So if you want to know more about all the clouds that are visible in this image, we can switch to the day microphysics RGB. So this time I will start with the recipe, and this is a, let's say, a easier RGB because there are single channels on all the color beams. So on red we have the visible 0.8, which gives us information about the optical thickness of clouds and about the surface. It means the redder the image is, the larger is the visible reflectance. On the green beam we have the infrared 3.9, and not the full infrared 3.9, but just the solar component of this channel, just the reflective part. So that's and that's the channel that gives us the information about the microphysics, because from this infrared channel we can say something about the cloud phase, whether it's a water cloud or ice cloud, and about the cloud particle size, because the bigger the reflectance, that means the smaller ice particles are there. So this is probably the most important part of this day microphysics RGB. And then on blue we have again the infrared 10.8, which gives us information about the surface skin temperature and also the cloud top temperatures. So it means the bluer the image is, the warmer are the tops. So enough of the theory. Let's look at the cloud picture. You see many colors there. And so where do we start? Let's start with the most prominent feature, these orange, reddish orange cells. And red or orange means or shows deep precipitating clouds with small ice particles. So there's clearly some rain on the way over there, over Eastern Europe. Then we have these pastel red colors, and they show us mid-level clouds. And you also have these pastel green colors over here. They are low water clouds, so they're sometimes a little bit mixed. You have this pastel green, pastel red, so those are always mid to low level clouds. What more can you see in this image? You have these greenish clouds over here. This is thin cirrus. You also see it over there. And you also gain some information on the surface skin as the infrared 10.8 is used. For example, you can see some snow over here in Norway. You see this pinkish color, shows you some snow. So again, you have very much information. You see very detailed which cloud is where. You know what level the cloud is. You know whether it's precipitating cloud or whether it's just a low-level cloud, thin cirrus. So all the information with just one image. So during the day, I always recommend you using the day microphysics RGB or the high-resolution visible RGB. There you gain a lot of knowledge about clouds. So, but what do we do during the night time? So you can always use the dust RGB, but there should be some more specific RGB, and that's the night microphysics RGB. So it's very similar. The recipe is very similar to the dust RGB. The main difference is that you have the infrared 3.9 instead of the infrared 8.7. And this RGB is mainly there for monitoring fog during the night. So let's see where we are now. We are at today 0 UTC, and that's what the night microphysics RGB looks like. It, as I said before, it looks a little bit similar to the dust RGB. The main difference is the fog. So the low-level water clouds appear in these greenish. Sorry, took the wrong marker. In this greenish, yellowish clouds over there, so it's really distinct, and you can easily detect where there's a low-level water cloud. And again, red are cold thick clouds. You see that our occlusion is further developing, and there's further developing, and you have a new wave development going on here. The occlusion over Central Europe is more or less dissolving, and here you have kind of like a new wave feature going on over here. And the more red you see, the thicker the cloud is, and the more likely is that there's some precipitation there also. So as time is running, I've shown you now different RGBs, and every RGB has its advantages and disadvantages, but I think there is no time during the day where there's not the ideal RGB to look at. Just that you know, you have to be careful with some RGBs during dusk and dawn, like the night microphysics RGB has some problems during dusk and dawn, as well as the day microphysics RGB. The reason is the infrared 3.9 channel, which can get contaminated by sunlight or things like that. You might also have some problems with limped cooling, but more or less just don't, just be active and really change the satellite image you're looking at, because there are so much benefits you can gain from using different RGBs depending on the time of day. And so as at least for Andreas and me, there's a prolonged weekend in the next few days, because tomorrow is a holiday in Austria. I don't know if it's a holiday for you, but I thought I'd give a quick outlook for the next few days for the weather situation. So here you see the water vapor 6.2 and the geopotential height in 500 hectopascal, and that's the actual situation as it looks now. So we have these upper level lows over the Atlantic and over Eastern Europe. And what will happen in the coming days is that these ridge will further develop, and then for the weekend it should look something like this. So we really have this nice ridge over Central Europe. So if you have a holiday tomorrow, I think you will all have some nice weather, at least in this region over here somewhere. And that's it from my part. I think time for questions is in the end, and thank you for listening, and I will now give the microphone over to Andreas.
Yes, thank you, Lily. Yes, I would like to conclude this weather briefing with a few slides about the Canadian wildfires. I think you all heard of them. The maximum of these wildfires was about 2 weeks ago. And I remember, I think in 2008, but please correct me if I'm wrong, there was a similar incident in Russia where a lot of woods were burning. So I collected some images, and I would like to show them to you what satellite images saw from these Canadian wildfires. So first start, where did it burn? This is a map of Canada from Google Earth. And I take my pointer. Fort McMurray is here. So it's in the middle of Canada. It's in the forest region. It's quite far north. And there were really big fires end of April and early May. And many people had been evacuated from this region. So the next slide gives us an information of the reason why at that time of the year and in this region the fires broke out. You see here the temperature anomaly chart, and it's temperature anomaly from April 26th to May the 3rd. So you see that it is too warm for that time of the year, and also much too dry. It's usually very dry in this region of Canada, but an additional fact is that it was much too warm, which favors the outbreak of fires. So this is a MODIS visible image. I took it from the EUMeTrain page. There is a short abstract on these fires done by Jose Prieto. And I see, or you can see here, this red arrow showing the smoke from the fires propagating over the northern part of Canada. It's a visible image. That means it's not only one image, it's a true color image. It's an RGB image, red, green, and blue, giving this natural, this true color image. So I hope you can see it, because this is a very short loop, a loop of 2 images. You see the day and night band in 0.7 micrometers. The day-night band is a visible image which shows the light sources also during the night, so it's very sensitive. And you see of course the lights from the factories, from the oil factories which are located in the north, and also from the fires. So from the day-night band, it's very hard to differentiate what is coming from a fire and what's coming from a natural light source, from a human light source. But if you take the other image, the 3.7 micrometer image, you clearly see that the fire is there where you have the green arrows. Because of the sub-pixel response of this channel, hot pixels are shown here in yellow colors because they are much hotter than the surrounding areas. I hope you could see all of them because it takes a few seconds to load. Okay, I will continue to the next one. This is a Landsat image with a very, very high resolution. It's not a meteorological satellite image. It's for other purposes. It has a resolution of 30 meters, so very, very fine resolution. And what you can see here is on one side the smoke of the burning woods in blue. I put a star in it, but it's very easy to see it. And you see also the brown burned areas here. These are all the burned areas. And you can also see, I put now a yellow star here, the still burning fires on the margin of these burned areas. So surrounding these burned areas, you can see the fires in this Landsat image. And I think it's very nice, and I have seen it on several YouTube videos, because it was used for information emissions and on TV. Now it takes again a few seconds to load the image, and these are 3 images. You have the visible image, you have the 3.7 again, showing the very hot pixels, and you have also the infrared image. And the infrared image, which is the top one, you can see, I pointed out here with my pointer, you can see here a very intense high-reaching cloud. That means with cold cloud tops. And this cloud type is called a PyroCumulonimbus cloud. This happens when the heat is very strong from the surface and convection sets on because of the large thermal instability caused by the fires. So this is an aerial view of such a cumulonimbus, a PyroCumulonimbus cloud. It's very impressive. The shape is exactly the same than from a normal cloud, but the source, the origin is different. It comes from the hot surface and protrudes high in the atmosphere until it reaches the tropopause. And on the tropopause, it's also, you see the anvil, so very similar to a usual cumulonimbus cloud. So this was, I think, my last image. I just want to no, I have another one. This is a ghost image. It shows the propagation of the smoke cloud, and it protruded from the north over whole America. I put a line with stars, and reaching the southern coast of the United States. So you see, it was really a global incident. It did not only affect Canada, but it affected, it's also here, vastly regions of the United States. So now let me conclude with a link I put here. There is a presentation, there was a presentation concerning PyroCumulonimbus clouds given by Mike from the United States. You can follow this link and have a 30 minutes presentation. It was given mid of April, before this incident happened in Canada, and it treats PyroCumulonimbus clouds and gives the physical background of all this. So follow this link, or you can also hear other resources which were of similar interests during this event week. So I hope you have enjoyed this event week and seen a few of these slides which were dealing with PyroCumulonimbus clouds and the fires in Canada. Yeah, and thank you very much, and I hand back to Liliane.
Okay, so thank you very much, Andreas, for your presentation. And so this is the end of the weather briefing. So if you have any questions, so I see no. If you have a question, just raise your hand. And while you're thinking about possible questions, I would like to advertise the next weather briefing, which will take place at June the 16th and will be led by the Hungarian colleagues. So there's a question. Massimo, I hand you the microphone. You can, if you press the control button, then your microphone should be activated. If you don't have a microphone at hand, you can type your question in the text. Yeah, I see it. Have your connections with the nowcasting stuff group? And this sentence seems to continue. So Andreas, I think that's probably more a question for you.
Yes, we have connections to the nowcasting subgroup, and we are also visualizing their products. We calculate them at our institute, and we put them also on ePort. So you can have a look at them on ePort. Not all of them, only from geostationary satellites, but I think most of them are available in ePort.
Also, they color clouds in different mode. Okay. So just that you know, because Andreas mentioned ePort, all the images you've seen in my part of the presentations were taken from ePort. So you can take a closer look at all these RGBs when you go to EUMeTrain's ePort, and I really encourage you to do that, because there you can put model fields and things like that over the satellite images, and you really have many possibilities there with our new ePort system. So really go to our EUMeTrain page and take a look at our new ePort system. So are there any other questions? It doesn't look like that at the moment. So thank you all for taking part in this weather briefing. All of you who take part in the satellite course, I think we will read each other in the forum again, and in 1 week there will be the playground session. And all of the other probably will see you again at some other EUMeTrain event, as just said, on June the 16th. There will be the next weather briefing. Okay, so thank you everyone for listening, and have a nice day.
Yes, thanks.